All right, here's the review for the test on parametric equations. This would be test 1. And the first question we're going to do is the set of parametric equations right here. We're going to create a table, and then we're going to graph the parametric equations. So first of all, we put in 0 for t into both equations and get our x and y values. So 0 minus 1 is negative 1. 1 minus 1 is 0, 2 minus 1 is 1, and 3 minus 1 is 2. So those are the x values. The y values would be 2 times 0 is 0, plus 1 is 1. 2 times 1 is 2, plus 1 is 3. Two times 2 is 4, plus 1 is 5. And 3 times 2 is 6, plus 1 is 7. And then we're going to graph these x and y values onto our graph. So we're just graphing these ordered pairs right here. So let's take a look at our graph. Okay, I'm going to go ahead and make this a little smaller so we can see the table and the graph together. There we go. All right, so we're going to plot these. So negative 1, 1 is right here. 0, 3. 1, 5. And 2, 7. And then we're just going to draw our arrows to show which direction we're going over time. Okay, problem 2 is a little bit different. All right, so for number 2, we have a parametric equations that are cosine and sine. They're trig functions, and we're going to use angles now for t so that we can find our values for x and y. So let's start with x. We're going to put 0 in for cosine t, which would be cosine of 0. Cosine of 0 is 1. 1 times 2 is 2, and 2 plus 2 is 4. So our first x value is going to be 4. Then we'll do it for pi over 2. Cosine of pi over 2 is 0. 0 times 2 is 0. 0 plus 2 is 2. The next one is pi. The cosine of pi is negative 1. Negative 1 times 2 is negative 2. Negative 2 plus 2 is 0. Then 3 pi over 2. The cosine of 3 pi over 2 is 0. 0 times 2 is 0. 0 plus 2 is 2. And then the last one, 2 pi. Cosine of 2 pi is 1. 1 times 2 is 2. And 2 plus 2 is 4. So those are our x values. And then we're going to do the y values. Sine of 0 is 0. So 0 times 3 is 0. Minus 1 is a negative 1. So our first y value is negative 1. Sine of pi over 2 is 1. 1 times 3 is 3. 3 minus 1 is 2. Then we're going to do sine of pi, which is 0. Sine of pi is 0. 0 times 3 is 0. Minus 1 is negative 1. Then we're going to do 3 pi over 2. Sine is negative 1. So negative 1 times 3 is negative 3. Minus 1 is negative 4. And then the last one, 2 pi. Sine of 2 pi is 0. 0 times 3 is 0. Minus 1 is negative 1. So now what we're going to graph are these values right here, the x's and y ordered pairs on our graph. Let me go ahead and make this a little bit smaller so we can see the graph and the table at the same time. There we go. And we're going to go ahead and start graphing this. So for -1, 2, 2, 0, -1, 2, -4, and then back to here. All right, so we have created an ellipse, which is, I'm sure, what we anticipated would happen. And the direction we're going is counterclockwise. So we'll draw our little arrows counterclockwise. And that's it. Okay, for problems 3, 4, and 5, we're going to eliminate the perimeter and write in the form of a rectangular equation. All right, so what we've practiced in class is that you solve for t in one of the equations and then substitute into the other. So in my examples 3 and 4, I'm going to go ahead and solve for t in the first equation and then substitute it into the second equation just for consistency. We could do it either way. We could do it the opposite way too. We could solve for t in the y equation and plug that into x, but just to keep everything consistent and even and the same so we don't get confused, go ahead and solve for t in the first equation, which is our x equals equation, and then substitute that in for y. So this is what the equation is going to look like when I'm finished. All right, so what I've done here is I went ahead and solved for t here. I subtracted 1 from both sides, divided by 3, so that gave me t equals x minus 1 over 3. I then substituted that x minus 1 over 3 into the next equation right here where this t is. So I opened up a parentheses where the t was, and I substituted the x minus 1 divided by 3. And that's the quantity squared. And then the rest of the equation is minus 5. And then the next step I did, I just simplified this a little bit. I went ahead and squared the top and the bottom, so I have x minus 1 squared over 9 minus 5. And I'm going to stop here, even though we could continue to simplify this. I'm going to go ahead and stop here just to conserve some time. And we're just going to put a box right around that. Because the main thing I want you to be able to do is convert from a parametric equation into a rectangular equation, which is what we get right here. And as far as simplifying this further, we could do that, but to save time, we're just going to leave it in this form right here. All right, let's take a look at the next problem. All right, in this equation, I solved for t in the first equation, which is x equals negative 2t, and I solved for t here, and I got t equals negative x over 2, and then I went ahead and substituted the negative x over 2 in for t here in the y equation, and I got y equals negative x divided by 2 minus 4. And then I just simplified it one more step. I went ahead and made this negative x over 2 into a negative 1/2 x minus 4. It's just a little extra simplification there that we can do. I wouldn't count it wrong if you did not do that, but it just looks more like a y equals mx plus b equation if we do that. So if you don't do that, though, I'm not going to take any points off. All right, so for problem number 5, the first thing you should notice is that this is a cosine and a sine. And since we have cosine and sine, we're going to use our Pythagorean identity to help us rewrite this into a rectangular equation. All right, so we know, if you've already been working on these in class with me like you're supposed to be, you would already know that this is either going to be a circle or it's going to be an ellipse. So let's go ahead and jot down our Pythagorean identity. Okay, so we have cosine squared t plus sine squared t equals 1. So this is our Pythagorean identity. We're going to use this to help us rewrite this. So the first step is to solve for cosine t and sine t, and then we're going to substitute those values in for cosine squared and sine squared, and you'll see how this works here. Let me just go ahead and write it out, and then you can see how to do that. Hold on. Okay, so I have x over 3 equals cosine t, and y over 4 equals sine t. And if we're going to use the Pythagorean identity right here, this right here, this is squared. So what I'm going to have to do with this term right here is I'm going to have to square it. So I'm going to square the whole term, and I'm going to replace my cosine squared t with this term squared. Because if we squared both sides, that's what we'd have right here. We'd have cosine squared t. Let me go ahead and write that out. All right, so what we're going to do next is we're going to replace, in our Pythagorean identity, we're going to replace our cosine squared t and our sine squared t with this x squared, x over 3 quantity squared, and the y over 4 quantity squared. And when we finish, we're going to have something that should look very familiar to you. All right, so here we have x squared over 9 plus y squared over 16 equals 1. And as you probably recognize right here, this is the equation of an ellipse. And so this equation up here, these two parametric equations, were the parametric equations for this ellipse. And we converted these parametric equations into the rectangular form of the equation of the ellipse, which is something that you should be able to recognize by now. Okay, so for problems 6 and 7, we're going to write the set of parametric equations for the given rectangular equation. So we're kind of doing the opposite of what we just did. Now they've already given us the x equals t. That's one of our parametric equations. That's our parametric equation for x. And what we can do with that is we can go ahead and substitute the t in for x into the other equation. So this is what we end up with after we do that. So when I substitute in, I get y equals 3t minus 2. So I substituted the t in where the x was. That's all I had to do. And these two right here are my set of parametric equations for number 6. That simple. All right, for number 7, you should recognize this as the rectangular form for the equation of an ellipse. And so we're going to do what we just did for number 5, sort of in reverse. So the first step is I'm going to set these two, the x term and the y term, equal to cosine and sine, and then we're going to solve, we're going to simplify it down, and then we're going to get our two rectangular equations. So let's just do this one step at a time. Okay, so I've rewritten these two terms, and I've set them equal to cosine squared t and sine squared t. And now what we're going to do is simplify these. We're going to take the square root of both sides, and then continue simplifying. We're going to solve for x and solve for y, and that will give us our two parametric equations. Okay, so here we go. All right, we have this x plus 2 over 4 equals cosine t, and y minus 1 over 5 equals sine t. And then we're just solving for x and solving for y. So we multiply both sides by 4. I get x plus 2 equals 4 cosine t, and then I subtract the 2. So x equals 4 cosine t minus 2. That's my x parametric equation. And then I do the same thing for y. I multiply both sides by 5, so I got y minus 1 equals 5 sine t, and then I added 1 to both sides. So I got y equals 5 sine t plus 1. And those are my two parametric equations for this ellipse. Okay, so for problem 8, we have Jim hit a golf ball with an initial velocity of 150 feet per second at an angle of 30 degrees to the horizontal. The following parametric equations describe the path of the ball. So you don't have to create your own parametric equations here. They're already given. So what you're going to do with this problem is you're going to enter these parametric equations into your calculator in the graph screen under parametric equations. And once you are there and you have your parametric equations graphed, then you're going to trace the graph to answer the questions. So the steps for entering the parametric equations are go to graph, then go to the menu button. You're going to push the menu button, and then you're going to go to graph entry, and you're going to select number 3, which is parametric equations. When you select that, the calculator is going to give you the x equals and the y equals. You're going to plug in your parametric equations into that. You're going to keep the standard time and t-step values that are in your calculator. Just keep that standard time and t-step values, and then you're going to hit enter to graph. Now you may not be able to see the graph. So if you cannot see the graph, then you're going to have to do a zoom fit. So you go to menu, go to the view or zoom menu, and then select the last one at the bottom, which is zoom fit. Once you do that, you should be able to see the entire parabola. Once you get to that point, then you're going to trace the graph. So you're going to go to menu, and then you're going to go to trace, and then graph trace. And then that will give you a cursor that you can move back and forth across your graph to find the different values. And at the bottom of that screen, you'll be able to see your x value, your y value, and your t value. And that's what you're going to use to answer the questions. Okay, so the first question asks, how long before the golf ball hits the ground? If you trace your parabola curve around until you get back to the x-axis, that's when the height is 0, so that's when it hits the ground. And so what you want to do is you want to look at the t value, the time value, and what you should get is something around 4.7 seconds. 4.7 seconds. That's what you should get. All right, then the next question is, when is the ball at its maximum height? Well, you want to trace back to the top of your parabola. So trace back to the top of your parabola and see what you get there for the maximum height. All right, so it should be right around 88 feet. So you're going to get the height from the y value. So when you trace back around to the very top of your parabola, look at the y value. The y value is going to be your height. In this case, it's right around 88 feet. The next question asks, what is the maximum height of the ball? That's the same question. So 88 feet. The next question asks, how far did the ball travel in the horizontal direction before it hit the ground? So again, you would want to trace back to where we were at the beginning, and where it was 4.7 seconds. Go ahead and trace back there and see how far it went horizontally. Okay, so that was about 611 feet. All right, number 9. Plane 1 is flying the following path. All right, so in this question we have two parametric equations, And we're going to graph both parametric equations at the same time in our graphing calculator. And we're going to see if those two paths cross, and if so, when. So let's go ahead and enter our two equations into our graphing calculator. You're going to enter them the same way that you entered the other one. When you get ready to enter your second equation, you're going to hit Control G. Control G will give you another set of equations that you can enter so that you have an x1 and an x2 and a y1 and a y2. So once you've entered both equations, you can see that the graphs look something like this. You have one line that goes straight up like this, and then you have one that kind of crosses around like this. So it looks like the planes will crash right here at this point. And so what you want to do here in your calculator is go ahead and do a graph trace. That's going to give you a little cursor. You're going to trace around until you get to this point, and then you're going to check to see what that time is. So let's go ahead and do that. Okay, again, that happens at about 4.7 units of time. And since the problem didn't give us whether this was hours or minutes or seconds, we're just going to say 4.7 units of time.